We have reached an important milestone: multiplication. Let's start from the simplest one, scalar multiplication. 5 times 6 is 30. 10 times minus 2 is minus 20. I think these 10 seconds on it are enough. It is much more interesting to investigate vector multiplication. So, let's take these two vectors. 2, 8, minus 4, and 1, minus 7, 3. If we want to multiply them, the condition is they must be compatible, or in other words, have the same length. All right. There are two types of products we can get. One is called dot or inner product, while the other, outer or tensor product. Here, we won't be needing the outer product, so you can read about it on your own if you wish. The dot product, however, is heavily used. When people talk about multiplying vectors and matrices, that's what they mean. Other popular names for the dot product are inner or scalar product. The notation is a dot, signifying it is the dot product. It works like this. We multiply each two corresponding elements and find their sum. For our case, the expression is as follows: 2 times 1 plus 8 times minus 7 plus minus 4 times 3. The result is minus 66. As you can see, we multiplied two vectors and got a scalar. That is why we also call the dot product scalar product. By the way, note that the dot product is nothing more than the sum of the products of the corresponding elements. In Python, we would need to declare the two vectors. Next, we will use the method dot provided by NumPy. So, np dot xy. This will give us the dot product, which is minus 66. Okay, let's see another example just to make sure you get the concept. The dot product of the vectors 0, 2, 5, 8, and 20, 3, 4, minus 1 is 0 times 20 plus 2 times 3 plus 5 times 4 plus 8 times minus 1. The result is 18. That's all. What about the operations from the beginning of the lecture? 5 times 6 is 30. This was a scalar product of two scalars that resulted in another scalar. All right. Finally, what happens when we multiply a scalar by a vector? Let's multiply. 5 times the vector, 2, 8, minus 4. When we multiply a vector by a scalar, we get a vector with the same length. Its incumbents are each multiplied by that scalar. So, for our case, we would get 2 times 5, 8 times 5, and minus 4 times 5. The result is 10, 40, minus 20. What's interesting is that the initial vector had been scaled 5 times. So, multiplication by a scalar doesn't change the shape, but only the scale of the values. Got it. That will do for now. In the next lecture, we will generalize this concept to matrices. Thanks for watching.